guys, so in this video we're going to be talking about just properties of limits. In the past we couldn't find horizontal asymptotes because we didn't have the strategies to, but now that we're introduced to the topic of limits, we can just say the limit as x approaches infinity or negative infinity when you have a fraction essentially. And that would send that equal to 0. Think about dividing by a larger number. If you put 1 over 10 in your calculator versus 1 over 100, 1 over 1,000, essentially you're going to see that it's going to approach 0. That's why if you approach negative or positive infinity, you're going to approach 0. There's no such thing as negative 0, that's why it doesn't really matter if you put in a large magnitude negative number. Now limit rules, limit f of x as x approaches a equals f, let's say, and then this is g. So what we can do is that if you have limits separated by a positive or negative sign, you can just split up the limit. Or you can just add the limits together. Same thing with multiplication. If you have limit of x approaches a of f of x times g of x, you can just do f times g. We're saying f is the limit of f of x and g is the limit of g of x. And the limit of x approaches a of f of x over g of x is equal to f over g, where g cannot equal 0 because we don't want that to be undefined. Now limit as x approaches a of c of f of x is c times f. The limit of x approaches a of f of x to the k is just the limit of that all to the k. If you have limit to that base f of x, then it's just that limit, base that to the power of the limit essentially. If you have limit of x approaches a of log, then you have log b of the limit, and then you'd have sine of the limit and cosine of the limit. So these are all fine and dandy, but I think what's most useful to you guys is kind of seeing them in action. But there's another thing you want to go over is that for polynomials, you just literally sub in the value of x, and that really is the limit for polynomials. So if you have something like, so when f of x equals polynomial, right? It's the limit as x approaches a of f of x, right? Just sub value of a. That's all you have to do. So if we want to find the limit, and I'll get out of the way, I know my back's blocking the camera, sorry. To solve this limit, we literally just sub in 1. So we go 1 squared plus 3 times 1 plus 4, which is going to be 1 plus 3 plus 4, which is 8. And then for this one, if you had the limit as x approaches 2 for root x plus 2, then what you get is root 2 plus 2, which is equal to 4. So you have the square root of 4, which is 2. You just sub it in again. This is not really the polynomial. It has a radical in it. But now if you had the limit as x approaches pi over 3 of sine of x over 2, then you would just sub in sine of pi over 3 over 2, and then you'd have sine of pi over 6, which is 1/2, essentially. So these are just a variety of examples for you to check out. There's one more for the road here. Limit as x approaches 0, e to the x plus 1 minus ln sine x plus 1. So you have e to the 0 plus 1 minus ln to the sine 0 plus 1 equals e minus ln 1, which is equal to e. Because ln 1 or log of 1 is going to be 0, essentially. Because anything to the power of 0 will give you back 1. So that wraps up limits for this video series.